Hello and welcome to Book Bites, a book club podcast for developers. We're continuing to go through seven languages in 7 weeks by Bruce Tate. And this week we're going through Clojure, which apparently is like Yoda. I thought that was a pretty good analogy for this one, especially since it uses prefix notation, which is kind of backwards from how we're used to doing things, and Yoda speaks kind of backwards.
Yeah, it is definitely a mind-bending type of language when you are used to anything that's not a Lisp.
Yeah. Okay, did you have any experience with any Lisp before this?
So I've actually done some Clojure stuff in the past. I read through, I think it was Programming Clojure like years ago. It's probably been 9 years or something like that. So it's been a while, and they had you implement Leiningen, which Clojure actually uses. It's common to use like a full-blown version of that as the way that you actually write stuff in Clojure, is like a package manager and task runner and so forth. But you build out like a small little wrapper around Ant using a Lisp DSL. And then I've also read The Joy of Clojure, which is kind of a like step above. So it's not necessarily beginning Clojure, it's a little bit more. And in that one, I have to say, like, that was one of the things that made me kind of appreciate how much thought has gone into Clojure through Rich Hickey and his creation of it, because there were a whole bunch of back references in it to other languages that had existed. And so it wasn't just like he came up with these ideas completely on his own, but instead he found things that had existed previously in white papers in other languages and decided to incorporate them in the way that Clojure works. I mean, somewhat language-wise, being a Lisp, I mean, there is influence back to, I think it was like John McCarthy in like the 50s or 60s came up with Lisp. Maybe I'm really off on the time frame of that, but long ago. And
in a galaxy far, far away.
Right. Which, I mean, as you read through, I don't know if the book mentions it, probably does. As for Lisp, do you know what that stands for?
Oh, it said it's a list processor.
Yes, because everything in Lisp is a list.
Yep. Yeah, so including code. The code itself is a list, which is really interesting.
Mm-hmm. And the runtime is just going and evaluating it, where you have an S expression being a set of parentheses, and like the first argument is the thing to go and look up and evaluate, and then everything following that is the arguments getting passed to it.
Yeah. So it said at the beginning that it's a Lisp dialect. It has more syntax instead of just using parentheses for everything. And then it's functional, but not purely functional. It has some limited side effects. And the other big thing about it is that it runs on the JVM.
Yeah. I think the additional syntax that it has kind of aligns with what Rich Hickey said, in that he wanted to make Clojure a more approachable Lisp.
Yeah.
And so like when you're reading it, being able to scan things visually. So, I mean, I thought of the example of when you are going and defining a function with the defn macro.
Yeah.
Doing that inside of Clojure, like you defn the name of whatever it is that you want to call that thing, and then a set of square brackets, which is kind of like breaking out of the list norm to display like what your arguments are.
Right.
Whereas in like other Lisp, like Scheme, because I've been exploring a little bit of Scheme variants, you write it slightly different in that you say define, and then as a set of parentheses, you give the name of whatever it is you're defining, and then the arguments after it. And then after that list, you give the body of your function or procedure. So it's a little bit different, and there's fewer parentheses involved in it. So that was kind of his goal. Is I think in the interview he actually says that there are too many parentheses in Lisp.
Mm-hmm. Yeah, so in Clojure, you use braces for maps, brackets for vectors. You can have commas for white space, which make maps a little bit easier to read because you need to have an even number of them for the key and value. And then it says you can omit parentheses in some places, but I didn't catch exactly where that was that you can omit.
Yeah, I'm not entirely sure on where it is that you omit them. I think probably if I were more familiar with other Lisp variants, it might seem a little bit clearer about where they're getting omitted.
And then it said it runs on the JVM, but it also mentioned running on or with the CLR, which is
Yes.
.NET.
Mm-hmm.
Do you know about that?
Yes. I mean, I don't know what the state of Clojure on .NET is, but that is one of the targets that at least used to exist at the time that this book was written or was supported. There's also been an uptick in Clojure that runs on JavaScript. So if you've heard ClojureScript at all.
Oh, yeah, okay.
Yeah, that is also Clojure that is compiled down to JavaScript, which is Clojure is compiled into Google Clojure's compiler to go and create JavaScript. So Google Clojure is a compiler that was like a big thing prior to like Webpack and so forth long ago, but it uses it because it's really good at optimizing stuff, and I don't know all the rationale behind it.
Wait,
but
is Google Clojure spelled with an S instead of a J?
Yes, Google Clojure is with an S.
No wonder I was confused about how to pronounce Clojure, because I've seen ClojureScript and I've probably heard of Google Clojure,
Mm-hmm.
but it's all pronounced the same.
Yeah, as far as I know. But there is like a common subset of Clojure that can work across both of them, because obviously like you can't write Clojure code that's touching Java stuff that works in JavaScript.
Oh yeah.
But there is some ways to go and have overlap between the two, so you can write both Java running Clojure as well as JavaScript running Clojure.
Okay. Yeah. So in the interview with Rich Hickey, it talks about how, I don't know, was Lisp a failure, and is Clojure more of a success because it's used in enterprise applications? And he said it just depends on what the intention is. And for Lisp, it never really was intended to be run on an enterprise level, I guess. But he wrote it to run on the JVM, and so it can work with a lot of existing libraries. But it still has a really steep learning curve.
Yeah, I mean, it definitely has its own ecosystem. It's not just like a thin wrapper over Java at all. It does, I mean, have the Java interop. I think we go through a little bit of it that is pretty smooth to go and reach into Java stuff that's there. But generally, it seems like if you stick to the Clojure ecosystem, then like you are going to have like a smoother experience working with it.
Yeah, maybe it was the Java interop that just helped it take off at the beginning when there wasn't as much written in Clojure yet.
Yeah, I mean, that is definitely a compelling factor to it, in that, I mean, you have the Java runtime that has seen millions of man hours of optimization put into it, and also that ecosystem is there. So if you already have like a shop that's running on Java, going and adopting Clojure, like there's definitely the language overhead, but you don't have to throw out everything.
Yeah. So prior to this chapter, my only experience with Lisp was glancing at a book called The Little Schemer.
Oh yeah, I actually just got that and have been going through it with a friend of mine a little bit.
Yeah, I just glanced at it because I was going to this meetup where they were going through that book, but I wasn't reading it, and it was weird because it doesn't. It seems like it doesn't actually explain the language. It's like a conversation or something where you kind of read through it and learn more syntax as you go?
Yeah. I mean, it seems like to me, going through that, you are learning just through the series of answering a whole bunch of questions, and you really don't need to have a computer in order to do it. At least in the earliest parts that I've been in, it's more just getting an understanding about how the language works.
Yeah, but I mean, speaking of having a computer when you're learning it, it's said that because of the number of parentheses, especially in standard, in I don't know if standard is the right word. In other Lisps, there's so many parentheses that you really rely on your text editor or IDE to help you find the matching parentheses and to maybe even write those matching parentheses as you go. Reading it in a book, I felt was really hard. I really had to focus on it, and I found myself like covering up the beginning and ending parentheses so I could see where things were.
Mm-hmm. Yeah, I can see that. It definitely takes time to adjust to reading it, because it's like if you're not used to all the parentheses, like your eyes are drawn to them a lot.
Yeah.
And I mean, like you said, there are helpful things in like editor tooling. For example, a common one is like rainbow parens.
Oh yeah.
And so
each matching parenthesis has a different color.
Mm-hmm. And
nice.
And then there are other things too, called like pair edit for parenthesis edit, where instead of going and like manipulating code line by line, which like something like Vim is really good at doing line editing.
Yeah.
And instead of doing that, you actually have a set of operations that work on Lisp forms. Like they have operations like slurp and barf, where
oh my gosh,
if
it's kind of gross.
So say you have like a list, and to the right of it you have a like something else that you want to include into that list. Rather than going and like deleting that parenthesis and then going and adding another like deleting that parenthesis, remembering to go over a couple of spaces and then adding that back in. Instead, you can go and tell it to do the slurp operation, and it'll go and bring it in. Or if you want that thing spit out, you can do a barf operation instead.
Okay.
Yeah,
that sounds really, really cool. It sounds kind of similar to some stuff you can do in Vim, where you're like change within the parentheses or delete within the parentheses.
Yeah, it's because the code is all structured the same way. Like it does open the possibility of working with code at a higher level than just like text or lines that it's on, but rather the forms that it takes.
Yeah. Okay. You want to get into day one?
Sure.
Day one talks about some of the basic forms. You've got Booleans, characters, numbers, keywords, and strings.
Mm-hmm.
Wait, I forgot what keywords were, actually.
So you have, let's see.
Because it's not like keyword. In other languages, keywords are reserved words by the language that you can't use that have special meaning.
Mm-hmm.
But in Clojure, it's different, right?
So in Clojure, you have like a keyword and a symbol, is it?
I think it's a symbol.
Yeah. And so one of them represents exactly itself. So like that is something that's prefixed with a colon. So
right.
So like colon list. That's probably a terrible term. I'm just looking at one on my screen, but like colon apple represents just colon apple. Like it doesn't really mean anything else or like evaluate to anything else.
So it's like symbols in Ruby or atoms in Prolog or Erlang.
Mm-hmm. Okay. Whereas a symbol in Clojure is something that represents something else. So like when you define a function, like if you define a function add, like that itself is a symbol because there's no colon prefix or anything. And when you use that somewhere else, like it gets looked up elsewhere.
Okay. Yeah.
Just like symbols in our world have some sort of meaning that they represent.
So symbol is like a variable.
Yeah.
Cool. Yeah. So I mean, right off the bat, it's more than just parentheses. And in prefix notation that messes me up. It's also, you've got different terminology for just basic variable type.
Yeah. I mean, I mean, other languages have that too, though. I mean, similar to what you said is like the languages have keywords.
Yeah.
Like, I mean, JavaScript having like for and in and if and all of those things.
Yeah, but they're defined by the language, and you can't add new ones.
Right.
Yeah.
And a lot of times in a Lisp, you have a small core, and then those other things are just built upon that. So they're not really like hard built into the languages like special symbols or anything. They are just defined using the small set of tools that are there.
Huh.
Like even things like defn.
Yeah.
For defining a function.
You said that was a macro, right?
Yes.
So that's a part of the language, but I'm guessing it's written in Clojure.
Yeah. So a macro, I guess, backing up, because we do a little bit of macro work in kind of chapter 2, but a macro being a bit of code that can evaluate during the first pass that the compiler takes over it. So like if it sees a macro, like it goes and expands that into other code before it goes and evaluates that code. So defn actually is short for def and then some name and then a function list. So like it winds up giving you a shorthand for it.
Huh.
And so like there's nothing special about it. It just happens to be a convenience thing because it's so common for you to create.
So macro is my notes here, I wrote that there's a step called macro expansion that occurs before Clojure implements or interprets.
Mm-hmm.
So it's kind of like a shorthand notation for more code. It's like an abbreviation.
Yeah, I mean, it is code that expands into other code.
Yeah.
So code creating code, which is really deep. And I mean, I don't feel like I would be at any level yet to be like, oh yes, of course, use a macro for that.
Yeah, and like I don't normally think about the compilation process and how, this code something will happen before it gets compiled. And no, I don't have to think about that usually.
Yeah. But I mean, they definitely are useful things for when you want to do a pattern, or like when you're doing something over and over that sometimes isn't accomplished by like a function.
Yeah.
Because I mean, sometimes the common approach that you see in most other languages is like encapsulate things into a function so you can, reuse them.
Yeah.
Like if you're doing the same thing over and over. And that gets you a long way. But sometimes you can't. Like if you want to like syntactically change the structure of something, like you can't do that with a function. And that is where like a macro can give you like greater power and freedom.
Yeah. And something it mentions in the conclusion is that about macro expansion. It says it's both a pro and a con because it's powerful in the hands of an expert, but it can lead to unmitigated disaster without proper thought and care.
Yeah. I recall once reading a guide to writing macros in Clojure, and it's like the first rule of macros is don't write macros.
That sounds like regex.
Yeah. And on the note of regex, that makes me think another language that does have macros, because it is not just unique to Lisp, was Rust. Actually, It has macros in it. It's not quite at the same level, because in Rust, like anytime you're using a macro, like you always have to add an exclamation mark to say this is a macro, start processing this here.
Okay.
It doesn't look like everything else, like it really sticks out. And a case that they use macros is actually for the usage of regex. So if you do a regex macro in Rust, then it can expand actually to a like a Lexer type of code, like piece of code at compile time.
Wow.
So rather than going and at runtime executing some like parsing and understanding the regex and compiling that at runtime, it instead can actually happen at compile time, so you can actually get yourself some performance benefit from it because it's compiled by the compiler.
Yeah, another thing you said about Clojure is it has no reader macros, which I don't know what that is, but apparently it limits Clojure's power, but it's on purpose because it decreases the likelihood that there's going to be any splintered dialects emerging. And apparently that was like really important to make sure there's just one Clojure dialect.
Having, I don't know, seen like the way that Clojure is written in the bits of code that I'm familiar with, it is true that like Clojure code kind of keeps itself feeling like Clojure rather than like if you did go super wild with macros, like you could go and write another language in there and it would work. Like if you wanted to write like SQL inside of Lisp, like you could do that and then have it get compiled back, like have the macro get compiled back into Lisp statements. And while you can do that at some level, that is also like if you go and create your own thing that is not understood by anything else, like your program it's not even in like just standard Lisp, but it's like your own dialect.
Yeah. Wow.
Which makes you think about like some of the advice that you get about like domain specific languages, where like, you know, your application should have a domain specific language, so then it aligns with, you know, whatever it is your business or application are doing. But it also is like you could wind up taking it too far.
Yeah. I've never had to work in a domain specific language. Have you?
I would say probably the closest thing to it that I've had to deal with is Cucumber.
Huh.
Or I guess Cucumber is the Ruby implementation of it, but it is Gherkin syntax. So if you've seen like requirements in terms of given, when, then,
Yeah.
where you go and you write a test, like given a user clicks the submit button and the email field is empty, then this, like given a user like has filled out a form and the email field is empty, when they click the submit button, then they should see an error. Is like the given, when, then type. And there are ways of doing that where you literally just write statements like that in English-esque sort of format with given, when, then.
Wow.
And I mean, the advantage of it is that you can have someone who's not technical write to that structure and be able to define test, and like ones that you haven't written yet just need an implementation. And it is one
the
case
theory,
where I think,
at least.
yeah, that's the theory. But what I kind of found is that when you actually do it, it winds up being that a programmer winds up having to write this Gherkin given, when, then syntax, and then write the underlying code that it gets turned into. And so then like you're kind of like doubling your work, because then you in order to accommodate the DSL, like you have to actually add the running code for it.
Oh, okay.
So I have not found it as ideal as a means of writing the test, or at least doing it on its own. I have found it useful for like just writing a test and sometimes like putting it there as a comment. So like using it as a way to communicate with like a project manager at work. Like I've used it for that, to get like clear cut like instructions of how things should behave, and then just like adding like comments into the test. But actually using that syntax as the DSL to run the test just seemed burdensome to me.
Yeah. Okay. And then beyond those basic forms, you also have collections. There's lists, vectors, sets, and maps.
Yep.
And they all use the different syntax. I think list is the only one that uses parentheses.
Yeah.
And lists and vectors are ordered. Sets and maps are unordered. Actually, what's the difference between list and vector?
So a list and a vector.
Yeah.
So a vector is something you can think of like a array, like think array in JavaScript, whereas a list is more like linked list.
Oh, okay.
So you get like when you add new things to it, it gets added to the head of it is like one major difference. Whereas a vector, when you add to it, it adds to the end. And when I say like adding to it or pushing onto it, you don't actually do that, or like they don't actually get modified.
Creates a new one.
Because Clojure has persistent data structures, which basically like means that they're immutable, like they cannot be changed. And so anytime that you go and add to a list, like you said, you always get a new one back. And the way that it's implemented is in a pretty efficient manner. So it's not like every time you go and add something to the list, are you creating a whole new list with like every time you add to a list, it's not going and creating an entirely new list, but instead it creates a single new list with one item in it that points back to the previous list.
Okay, nice.
At the end of it. And Clojure has like ways of efficiently doing that as well, like where you don't wind up having just like memory explosion with the way that it's implemented. I believe that those things are actually implemented directly in Java in order to get high performance out of them.
Okay. Yeah, and then you've got functions, named and anonymous functions, and you can do destructuring of the parameter. It also mentioned like if you want to hide the fact that you're destructuring from any client of that function, then you could just destructure as the first line inside the.
Interesting. Yeah, missed that snippet, but that makes sense. Like if you're pulling like the documentation that shows the function signature.
That's pretty much day one. I basically tapped out on the doing the exercises in this chapter because it was just so hard. And we tried to go through this chapter like months ago, and I was like, I don't know about this. It's way over my head. It's really hard. And I know I went through some of the exercises then, but I think I didn't commit them, and then I wiped that computer, so I have no record of it.
Well, I mean, it's all right. You can maybe go back through on another day.
Yeah, when I'm feeling
now that you've read a little bit more, but I went through both of them. I mean, first one is creating just a function that I called it big, and just as I said, and so it's just like defining a function and having to write it in the Lisp syntax, which I do have to say it is a little bit strange at first using the greater than operator, but doing it in a prefix manner.
Oh yeah, I thought it was really cool how you could use the greater than or less than, and then just a bunch of numbers after it. And if it's ordered, then it returns true. The whole list. It's just a way to check if the whole list is in order.
Yeah, I mean that is one advantage that you get from prefix is that you don't have to have a fixed arity. Whereas like if you have an infix operator that goes between two things,
then it's a binary operator.
Binary.
It only takes two operands. Yeah. So you could just say plus and then a whole bunch of numbers, and it just adds them all up.
Yeah. And then
so basically it's doing a reduce.
Yeah. It is kind of an interesting thing. I've never reached for it with the comparison operators. I think the first place that I saw it was with adding, and then it made a lot of sense. I guess one other benefit that you get from it is that you have like known order of operation, because if something needs to get evaluated before something else, it is inside of a set of parentheses.
Oh yeah.
And you don't have that case of like, wait, does and get applied first, or does or get applied first? And I don't know, the number of times that I've screwed up in code just relying on that, and thought it worked all right.
You know what I do now for that in JavaScript?
Put parentheses.
I put all the parentheses that I need, and then I let prettier remove them if it doesn't need it.
No, Hey, that's getting the computer to work for
Yeah.
you. And then it also had, like, you implement a collection type function, but given a certain collection, you need to return like a keyword of what it is. So if it's a list, you give back a keyword of a : list. And for that, there is a function available in Clojure called cond, COND, for condition. And you can think of it like a switch statement where, I mean, the major difference being that you're not stuck with just like a fixed value for the first argument of the switch. Like in a JavaScript switch, like you can only do like a string value or a numeric value or something.
Yeah.
Like you can't go and perform a function call.
Right.
But anyways, I used that to say, like, is it a list? Because list ? Is a way of asking if something is a list. If it is, give back list. If it's a vector, give back vector.
Okay.
And so I did that, and so wound up being like 5 lines, pretty clean. And then as an expansion of that, kind of aligning with chapter 2, they talk about protocols a bit. I also took an approach to use protocols as well to extend the types to be able to ask them what type they are.
Yeah, can you explain what a protocol is real quick?
Sure. Yeah, so a protocol, if you've worked in like a language like Java or C#, you can think of like an interface.
Okay.
And it is something that says this, like, given I have this type, like it can like implement a protocol, and if it does implement that protocol, then it needs to have like these functions implemented for it. So like I made the protocol, def protocol of what type.
Okay.
And which is like Pascal cased, because that seems to be the common way to name your protocols. And I said that there needs to be one function implemented for that type of the protocol, is what dash type, and then it takes a single argument. Like, and that's the definition of the protocol. And then for extend, and then in order to have things implemented in Clojure, they have what's called extend type, which this is not like a Java available thing, because you can't go and add methods onto things in Java. I mean, you can add a method that takes in something of that type. Like you can just have like some static function that does it. And I think that's probably what this does under the hood. But I can say, like, I want to extend clojure.lang.persistentVector to implement the what type protocol, and then say, like, here's the name of, or like, here's this function, and here's how it's implemented. And it just, persistent vector always returns vector. So
Okay.
just as like a different way of implementing it. It's definitely more verbose in order to go and do it, but it was kind of cool that I was able to like extend that type or add an implementation that was specific to that type.
So you went and extended
persistent vector.
Persistent vector. What is persistent vector?
Which that is just a vector in Clojure.
Did you also extend lists and maps?
Yeah, so I did like persistent array, which it's a persistent array map, and then persistent hash, and then persistent list. Like all 4 of those are like built-ins to the language that I was able to go and add that onto.
Interesting.
Yeah.
Yeah, so chapter 2 starts off by talking about recursion, which is an important part of any functional language, but the JVM doesn't support tail recursion. So there's this syntax you have to use where you use a keyword called loop and a keyword, well, I say keyword. You use loop and recur. And I'm not entirely sure what that's doing behind the scenes, but it lets you do recursion in an efficient way, even though the JVM doesn't support tail recursion.
Yeah. So as for loop and recur, I mean, I think we've talked about tail call optimization in the past, but
yeah,
basically it's a way of writing a function that like just in general, tail call optimization is a function that calls itself as its last operation. Like there's nothing else that happens after that. And so like if you need to have state of any sort, like you pass it in as an argument
yeah,
to that function again.
yeah,
And by doing that, you wind up not building up a stack.
yeah.
Like the same position on the stack can get reused with just updated arguments that are passed into it.
I'm guessing what loop and recur does behind the scenes is it looks like a recursion call, but it probably changes it into a for loop or something. Changes it into a loop.
Yeah. I mean, that's likely what it does because any tail call optimized function can become a like while loop or so I guess it would become a while loop because your base case is basically the condition of the while loop.
Yes.
And if it ever reaches that, then you wind up breaking out of it.
Yeah. The base case is where it just returns something.
Right, where you say if this condition, then stop recursing.
Return 0 or something.
Right. Yeah. Return 0. Return some identity value.
Yeah.
That was actually like one of the golden rules in the book, Little Schemer. Like right at the beginning, they put it in there. Like if you're recursing and it's over numbers, then always give back 0 if you're adding, or 1 if you're multiplying.
Yeah.
Or an empty list if you're going over like if you're returning a list.
Okay. Yeah.
And then they get on to sequences inside of chapter 2.
Yeah, so it said sequences is implementation independent abstraction around all of the container types.
Yeah.
It wraps sets, maps, vectors, and things like that. So it just has common abstractions for those.
Right. So you can use things like head and map and reduce, and you can use them on like any of the collection types.
Yeah, there's every, not any.
Mm-hmm.
And I like how these end with question marks because it returns a Boolean.
Mm-hmm. That's definitely like a Rubyism.
Yeah.
That I can see there.
It even talks about list comprehension, which we talked about with Erlang.
That's right.
List comprehension still blows my mind, but it's really cool. It's like you can combine multiple lists and filter them and do some sort of map operation as well, all at the same time.
Yeah, like you have like map and filter, and if you want to get like all combinations of multiple things, like of multiple collections.
Yeah, it's really cool.
Yeah, I know I had to use it in Erlang for something a while back. I was doing like I think it was a cracking the coding interview problem where you had to like rotate an image by 90 degrees, and so you have a bunch of pixels, and so like you needed, like it was always a square image, but you needed to rotate it by 90 degrees, and it was like, how would you go and do that? And because Erlang doesn't actually have a like looping construct outside of either recursion or list comprehensions. Comprehensions worked really well for saying like, given these XY coordinates, map them to these XY coordinates that are 90 degrees away.
Yeah. Huh.
Yeah.
Yeah, and then it talks about lazy evaluation, lazy sequences, because you can have like infinite sequences. And so It wouldn't be able to, I don't know, work with that, like, or actually store that much information. And so it's lazy and it just doesn't do it until it needs to.
Mm-hmm. So, yeah, like you can continue to pull things off of it forever until you run out of memory or time.
So, I mean, you can just create an infinite sequence with repeat mm-hmm. some value, and then you just got a list with that thing infinite times.
Yeah.
And yeah, like stuff like this is very useful. Like I know sometimes in JavaScript I've been like, how do I create, I don't know, a new list that just has a bunch of things, and there may not be a great way to do that. But here you can just like repeat, cycle, or whatever, and take a certain number of them off.
Yeah. It's definitely a different mindset and approach to it. Thinking like thinking in the infinite.
Yeah.
And like being able to have that available, but then also knowing like you do have to use caution to limit yourself. So like using things like take is something that is important to say like I only need this many.
Yeah. And then here it talks about how you can get a lot of parentheses when you're doing stuff like this, and you have to read it from the inner parentheses to the outer parentheses. But Clojure has this new left to right operator, so you can actually do dash greater than, and then you can read it from left to right.
Yeah, it is the thread macro. And what it does is it takes like whatever is like the first argument of it is, it puts it in the last position of the list of the next argument. And it takes that and it puts it in the last position of the next argument.
Okay.
So, I mean, that is something that you can go and there is macro expand inside of Clojure. You can go and see like what it actually gets turned into.
So it's just going to turn it back into your normal parentheses instead of parentheses.
Yes. But if you have like a longer flow of operations, like it can be useful for that to avoid nesting.
Yeah. I can imagine working in a code base where one person prefers nesting and another person prefers this operator. And then you're just arguing back and forth and changing and like having inconsistencies.
What if, like, I mean, getting deep on it though, like given it's all structured, right? Like, I mean,
you could just choose which one you want, and you can edit it. Like you could see it one way, and then it gets committed a different way.
Yes, yeah, like being able to do that, like because you can actually with Git, like you can tell Git like when it extracts code from the object files to do it in a certain way, and then before it puts it back in, like it will go and change it out.
Yeah, but I think like, ideally you just use this sometimes when it's nicer.
Yeah, like I think it depends on the case of it, but like if you have a lot of steps that something has to go through, I mean it definitely is nice for that. I used it in a different language recently. I think I told you about it on Discord. I used a language called Janet, which is a Clojure inspired Lisp, but it is not running on the JVM. Like it compiles down to its own bytecode in VM. And I wrote an implementation of what's called Nano ID, and it lets you generate a random ID using Janet. Like there's an implementation in JavaScript, and there's one in Clojure, and I don't know, there were a bunch of languages, but Janet did not exist as one. And so while I was dabbling with it, it was one I tried out. And because it's Clojure inspired, it has a lot of the things from it. One of them being the thread macro. And there was definitely like one case where I had to pass something through a couple of steps, like pass it from one function to the next function to the next function. And the thread macro was definitely like the clearest option to show that, because if you break each of the operations down between lines, then it can kind of become clear. Because even in like a non-Lisp language, like that can become pretty hairy pretty quick. Like if you have a function that passes to another function that passes to another function.
Yeah. Do you want to talk about any of your solutions to day 2 or day 3? I don't know if we're gonna have time for both.
Okay. I mean, I can talk about day 2.
Okay.
So
yeah, what problems did you do in day 2?
Yeah. Let's see. I'm pulling up. So I did first the Fibonacci's as a infinite, I guess, lazy sequence using the iterate function in order to do that. And what iterate does is it just keeps calling the same function over and over, passing it the previous value that was there. So think of like a reduce, but there's no list that it's going over. So all you get is the previous value there. And so I was able to do that, make an infinite Fibonacci list and implement it that way, as well as doing it using, there is the lazy seek, like a lazy SEQ method that also is available.
Okay.
And if you have a function that conjures a list, so conj like conjoining, creating another list with something at the first position, like if you put a lazy sequence at the tail of it, then it will also be a lazy sequence that has another lazy sequence following it and following that. And I figured I would just try out that approach too. As for which was nicer to do, I think I leaned towards iterate. It was a little bit clearer to me rather than going down the path of recursion.
Yeah.
But I could see that the other one might potentially have like greater flexibility when you need something other than just looking at the previous value. And then the other thing that it asked to do was going and implementing the unless macro. And unless is just the opposite of an if.
Yeah. Yeah.
So, like, I don't know, like have stop unless the light is green or something.
I have to read that backwards whenever I see an unless in code. I have to read the stuff that it does and then say unless and then read the condition. It's so weird. I can't just, it's hard for me to read the unless and the condition first.
That was one thing that that Ruby had.
Yeah.
Where, I mean, unless actually comes in the last position.
Yeah.
And I don't think that I would necessarily reach for unless in a normal case, because you're already thinking in the negative. And if that is a negative thing as well, then like unless I'm not going, like yeah. But with that, from the macro, like returning a list, and then you do what's called quoting, which is where you put like a single tick to say, don't evaluate this thing, but rather like don't evaluate it during macro expansion time. Right. And instead like just use that symbol, like put that symbol value there like when it actually gets evaluated.
Yeah.
And so that was one thing that I implemented. And then to go along with it, I looked in and was like, man, this is kind of kludgy, because like you're creating a list and then you're creating another list. Like every time that you need to create a list, like you are calling the list function to go and construct a new one. And I was like, can't I just go and quote this whole thing? And there actually exists another type of quoting that is using the backtick. And if you use that, then you have the ability inside of that quoted form to go and unquote using the tilde.
Okay.
And so what it allows you to do is actually write in a syntax that is closer to what it gets expanded to. Because it's saying like most of this stuff should be quoted, but then some of this stuff just needs to get unquoted.
That's interesting.
So I have an article that I can send you to that way that was pretty informative on how to write macros that way. And it kind of goes through like writing it in this form where you're just like quoting things that you need to the flip of it. And then it even goes on to say like you can actually go and reduce repetition in it by using a map inside of your macro, because I mean you're evaluating your Lisp right there, or you're evaluating Clojure during macro expansion time. So you have things like map and reduce available to you if you want to use that then. And they do. It's pretty mind-bending. But
yeah, I don't even understand, but it sounds really powerful.
Yeah. So that was cool. Chapter 2.
Yeah, chapter 3 is all about concurrency, and I kind of just glazed over as I was reading through this. My big takeaways is that there's different ways of doing it. There's refs, there's atoms, there's agents, and it also mentions futures. I'm not sure if that's a way to, I mean, yeah, that's another way to do concurrency, I guess.
Yeah.
Futures are like promises. That's the one that I understood most out of all of these.
And there is also now in Clojure a set of utilities called like core.async, which gives you channels. So if you've worked in something like Go and used Go routines, then it allows you to have like a buffered structure to pass things between like consumers. And yeah, that's just something new since the book was written as well, that exists.
Yeah.
But that, I think that is that's a common thing amongst Clojure, though, is just having lots of concurrency options. So you're not going and writing all sorts of locks all over in your code.
Yeah.
Like you're never going and like acquiring a mutex or something and saying like, hang on, like stop what you're doing until, like I let this thing go. But by having things like immutable data structures, like you're not having shared memory, like mutable shared memory. Like, so that helps you on that front. But then in the cases that you do need to have that, that's the case where you have something like an atom that like allows you to atomically access a value, like access and update a value in like a given thread.
Yeah, I mean, it seems like it would be hard to choose which way to do concurrency depending on the situation. I don't know how you choose between them, like as you're just writing code. But maybe that's just me, and I don't have enough experience with this.
I mean, yeah, like that's one of those things that is very like situation dependent, and like even I don't like I don't always have the perfect idea up front. I mean, some of it's using like what you know,
Yeah.
But
it seems like you could sit there and spin your wheels for a while saying, well, we could do it this way, or we could do it this way, or could do it this way. Well, which way should we do it? Well, this way has pros and cons, and this way has pros and cons, and this way has pros and cons,
Yeah, I think I did read that agents are a less used type thing anymore, in preference to use the like core.async type things. Like, I mean, that seems like the most blessed way that I can
that's
find
what I was about to say. Like, I just
days.
want a blessed way.
Mm-hmm. And that, I guess, I mean, that's probably even one thing like with a Lisp that may be harder to find in some cases, is because you can like meld it and mold it to whatever way you want.
Yeah.
Like some of the opinionated sides of it may, like, I don't know, that may not always be the right way. It's like even me going and implementing like lazy sequences and protocols like in various ways. Like, it's just what you do, I guess. Like, you find what works, and then, I mean, it's probably up to like you and the team of people that you're working with to find the way that's most effective.
Yep. All right. Yeah. So the conclusion of this chapter talks about the Lisp paradox, where it has some really good strengths and has some weaknesses as well. The strengths are it's a good Lisp. It's got reduced parentheses. It's got a good ecosystem with all the Java libraries. And then it shows restraint. It's got good support for concurrency, lazy evaluation, and data as code. But the core weaknesses, these really stand out to me. The prefix notation, I could get over that. I could get used to that. Readability, and then learning curve. I said the learning curve is oppressive and it takes time to master. And I could feel that just going through this chapter. Normally, so far in this book, until I got to this chapter, I thought, oh yeah, I get this. I can do more in this language than I thought I could in the short amount of time, but not with Clojure. And then another weakness is that no tail recursion optimization. You have to use loop recur, and accessibility. It has so many abstraction tools and concepts that it can just be really overwhelming.
Yeah, I could certainly see and agree with those things, like the learning curve. Even just getting like a development environment set up with Clojure is something that I feel like isn't quite clear yet. I mean, the book talks about using something like Leiningen to get going, but there's also Boot, and there's also Clojure now has some standard tooling with it that is like the CLJ tool that can go and resolve dependencies for you.
I remember asking you when I was first getting set up, like, okay, what are you using? Are you using Leiningen? And because I didn't want it to be one of those situations again where I was having trouble because I was just using straight them and some other setup and making it harder on myself.
Yeah.
But I mean, with all the weaknesses I just mentioned and my struggles with it, I'm still really interested in intrigued with it because it seems really cool. And I want to go through a book like The Little Schemer.
I was actually just going to ask you with that, like if you're interested in like hopping in on that. I mean, we don't necessarily have to do it as a recording on here, because I don't know how that would fare. Maybe it's just like a final follow up to it. but I have been looking at a couple of scheme variants, because like a scheme is kind of like a standard set of Lisp, because they're like within Lisp there are families in it. Like there's like common Lisp, there's scheme, and then Clojure. It's kind of its own deal, but there are variants off of that. And so yeah, if you're interested, like let's talk after.
Sounds good. You have any other final thoughts?
I would have to say that like I think Clojure like was definitely an eye-opening language for me to experience like the whole notion of like code as data, and like being able to just say, well, this is just a bit of data that's getting passed in simply by adding like a quotation mark in front of stuff, and having it be all structured the same way. It's definitely like something that has a learning curve to it, but I could see some serious value in it. I think the thing that intrigued me most about Clojure, like, and why I even initially looked at it, is I went to a Ruby user group, and when I was at that group, there was a person who came there that I'd never seen at the group before, but he came to talk about Clojure, and he talked about why Clojure was great, and everybody like shot questions at him of like, well, how do you think that having all those parentheses is beautiful? Because I mean, Ruby like avoids parentheses if it can, when it can. And he just like he had like a solid answer for everything. Like he was able to hold his own against like a whole room of Rubyists to say like this code is like objectively like more beautiful than your Ruby, and like here's why, because it's consistent, because I have the power to like meld it to my will. Like I don't know. He just like had all sorts of like awesome answers, and so like that's what drove my interest. So
yeah, that sounds really nice.
Yeah,
cool. Well, next time we'll be wrapping up the book with Haskell. I'm excited about that, and especially just excited to finish this book, because we thought it was going to be 7 actual weeks, but we took a long break. Listeners may not realize that we just had a bunch of episodes in the queue and read some other books in between. So
it's all right.
Yeah, if you want to follow the show on Twitter, and you can find the transcript and show notes for this episode at orbit.fm/bookbites. You can follow both of us on Twitter as well. I'm at AGARR. Did I get that right? AGARRHARR. And Jason, you're at Staten Jason.
Yep.
If you haven't already, we really appreciate you going and giving a star rating, at least in iTunes. And if you wouldn't mind saying something nice, that'd be awesome. So until next time, see ya.
See ya.